Hey everybody, today we have a cubic polynomial with three distinct real roots, and one of these roots is -3, so we're supposed to find this unknown coefficient of x. Now without loss of generality, we can just go ahead and say c is equal to -3. Okay, and again, a, b, and c are distinct, and if you expand this out, anytime you have a root, you have a corresponding linear factor. So a is a root, you have x minus a is a linear factor, and so on. When you expand that out, and this takes a little bit of time, and it's a little error prone, but you get this nice representation where the negative sum of the roots is the coefficient of x squared, and then the pairwise products of the roots summed together are is the coefficient of x, and finally the product of the roots is minus abc here. Okay, so we can work with that actually by just equating the coefficients, and that's what we do right here. Notice that we take this coefficient minus the sum of the roots and set it equal to 7120, which is the coefficient in the polynomial of interest. Okay, 71 over 120. Okay, and then also the products, the pairwise products, is equal to s, and that's ultimately what we're trying to find. And finally, 3 is equal to minus abc, and again we're just equating this constant term with 3 right here. Okay, now I've done most of the work here, but notice that since we assume that c is -3, I'll write it down here again. If c is -3, it follows quickly that the product of the other two roots have to be 1, and that means they're reciprocals of each other. Okay, now that comes in quite handy here because we can actually replace b with 1 over a. In other words, this can be rewritten as b is equal to 1 over a. Okay, just a simple, we divide through by a, and we get b is equal to 1 over a. So you see, that turns this one equation and two unknowns into one equation and one unknown. I simply replace b with 1 over a. Notice this minus sign comes over here to the 71 over 120. All right. Now this is just a quadratic, and all I'm going to do is complete the square, which is kind of nice here. All of this stuff is equivalent all the way down, and we get to a stage here where we actually complete the square. And you guys remember the process there. You take 1/2 the coefficient of the linear term. So the linear term is 289 over 120. 1/2 of that is 289 over 240. 2 times 120 being 240. Okay, and the rest of this, now this ends up being kind of some, it looks hard, you know, but notice something very nice here. This is just in the form of a squared, this top part here, a squared minus b squared is equal to, this is the well-known difference of two squares, a squared minus b squared is equal to a plus b times a minus b, and that's very well known because when you multiply this out, the cross terms just cancel. So we got this going on, and you can see exactly how this happened, folks. You see, this 289 plus 240 is 529, and 289 minus 240 is 49. Both of those turn out to be perfect squares. So when you take the plus and minus square roots, see how this exponent goes away, and then 23 squared is 529, and 7 squared is 49. Okay, so folks, again, I'll omit, but you get two different answers. Now you can just assume that a is you know, since this is symmetrical, you can go ahead and assume that a is equal to 15 over 8. All right, and now remember that, and it works out either way. You could assume a is equal to 8 over 15 too, but if a is equal to 15 over 8, well, remember that b is equal to 1 over a. Okay, so b is equal to 1 over a, but that's 8 over 15, excuse me. That's 8 over 15, right? So you see, we have all the roots right now. We know that a is 15 over 8, b is 8 over 15, and of course, one of the roots is -3. It was given, right? So let's go on down and solve this. Okay, so folks, I'm just doing direct substitutions, and again, remember, c was given to be -3 here. Okay, c was given to be -3. And so if we carry on right here, let's see what we get. This would be what? 1 minus 24 over 15. Right? 3 times 8 is 24. So you have 24 over 15 here. And then plus, what's this, 45? 45 over 8. Excuse me, 45 over 8 is all equal to S, right? Which is what we're looking for. Okay, now we just have a little bit of arithmetic ahead of us here. So this is what, 1 minus, let's see here, your common denominator will be 8 times 15, which is 120. Okay, and then 8 times 24 is 192. This is kind of what some people call cross multiplying, although technically that's not what we're doing. And then 15 times 45 is a little bit of a problem to do in your head, but that's 675. Okay, so let's keep on sliding down here. So that would be 1 minus 767 when you add these up, right? 867, excuse me. So that's 867 over 120. Okay, now let's see. Can we simplify this any further? This would be, y'all, and I'm going to leave out one of the steps here, because this would be 120. And so you would have 49 over 120. Or you'd have, let's see, your minus 7, let's see, your minus 740, what do you got there? Your 20, y'all? Is that 7? Yeah, minus 747 over 120. I believe that reduces to 249. Yeah, 249 over 40. 3 is common to both of these, right? 3 times 249 is 747. 3 times 40 is 120. So you would have minus 249 over 40. So a little bit of arithmetic at the end, but that's our solution. So this is equal to S. Okay, and that is what we're looking for, folks. And again, maybe some mistakes in the arithmetic. I don't think so. I think it's minus 249 over 40. And again, it was kind of neat here what we did. This is not a standard college type question right here. If you look at this part right here, not a lot of people are going to be too fond of completing the square right here, but that's what we did on this step right here. Going to this step right here, I'll write down CTS. Stands for complete the square. You could try the quadratic formula, but you can actually use complete the square to prove the quadratic formula. So anyway, I think we got the job done there. S is equal to minus 249 over 40. Talk to you later.